In this exercise, we are presented with a joint probability distribution function for the random variable x and the random variable y. X can take the value 5 or 10, y can take the value 1 or 2, and we can see that because all of these probabilities add up to 1, if this is a well-defined probability distribution function, then the pairs of outcomes must be mutually exclusive. So in part A, we're asked whether or not x and y are independent random variables. Now remember, two variables are independent if the conditional probability, so in other words, the probability that x is equal to a particular value given that y is equal to some particular value, is just equal to the marginal or the unconditional probability, and that would need to be true for all possible values of I and j. So a good place to start in trying to answer this question about whether or not they are independent random variables would be to calculate the marginal probabilities. So let's start by looking at our random variables. So in order to calculate the probability that x is equal to 5, for instance, all we need to do is, because these are mutually exclusive pairs of outcomes, we just need to add up all of the probabilities, or all of the joint probabilities, where x is equal to 5. So the probability that x is equal to 5 is going to be 0.3 plus 0.2 is equal to 0.5. Similarly, the probability that x is equal to 10 is 0.4 plus 0.1, which is equal to 0.5. For y, the probability that y is equal to 1 is 0.3 plus 0.4 is 0.7. And similarly, probability that y is equal to 2 is 0.3. So we can write all of those down. Now, we don't yet have enough information to say whether or not they're independent, but in order to address whether or not they're independent, let's try and answer part B. So suppose that you observe that y is equal to 2, what's the probability that x is equal to 5? So in other words, conditioning that y is equal to 2, what's the probability that x is equal to 5? So the probability that x is equal to 5, conditional on y being equal to 2, is just equal to the joint probability that x is equal to 5 and y is equal to 2, divided by the probability that y is equal to 2. So in other words, we're looking at what proportion of the time when y is equal to 2, so this part, 0.3 of the time y is equal to 2, what proportion of the time when y is equal to 2 is x equal to 3. So it's 0.2 over 0.3, which is equal to 2/3. So this is the conditional probability that x is equal to 5 given y is equal to 2, but we know that the unconditional probability that x is equal to 5 is equal to 0.5, which is not equal to 2/3. So therefore, x and y are not independent.